a few announcements to make before we get started. Please silence your phones and step outside if you have to make a call. In case of a fire and emergency in the building, exits are clearly marked, and we encourage everybody to make the decision that best suits your comfort level to get out. You all have the mobile app, I hope, and are using that to rate this session and others today. Don't forget there is a networking reception from 4:30 to 6 this evening in the Grand Ballroom, and tomorrow morning the keynote session starts at 8:45. Conference feedback is always welcome, so open your app and please rate the session, and you'll have a chance to enter and receive a full complimentary registration to next year's Microgrid conference. So with that, again, good afternoon. I'm Alan Schaefer, Executive Director of the Engine Technology Forum, and your host for this sponsored session, and I'll be moderating today's panel. But it's great to see everybody here. We are let me just move on here. A little bit about us. For the previous 23 years, we were the Diesel Technology Forum, but like many, we have evolved in the last year to take on a bigger role, and that is as an advocate for the future of internal combustion engines. We feel very strongly they have a continued role to play, using both new renewable fuels and existing fuels to power our future. And these are our members, and I'm delighted to have two of them here with me today at our session. As I've alluded to a little bit, we see the world in this way, that advanced internal combustion engine technology, working alongside some other technologies, all electric, hydrogen fuel cells, hydrogen internal combustion engine, together this diverse array of technologies represents what our future might look like. And the future can use a whole range of fuels. As you know, internal combustion engines have a great ability to use different kinds of fuels, from conventional fossil fuels to a whole range of new kinds of fuels listed there on the right. And so that is particularly important today as we think about our work towards the clean energy future. So that's all from me, and I'd like to now introduce our panelists. Our first panelist is Mike Sanford, and Michael is the Business Development Manager for New Energy Solutions from Cummins. Michael?
Hey, good afternoon, everyone. Great to see you all here. Great to see the room packed. There we go. I always struggle with these podium mics being a little short for me here. Once again, glad to have you all here. Hopefully everyone has a good visibility of the screen, although I do see that it's not currently projecting over on the right-hand side, so let me go ahead and just troubleshoot that. There it is, much better. Okay, I'm going to cover a couple of major topics today. I'm going to try and move through them swiftly to allow a couple of things. One, our other panelists here to move forward and talk about some of the similar concepts. And likewise, I want to leave a sufficient amount of time for questions. We want this to be interactive, so I do want you thinking about questions as we go through. I'm confident that there may even be writing utensils or scrap pieces of paper on the table in front of you, so please do write down those questions. We'd love to talk afterwards and answer any questions that you may have. Hopefully everyone, I hope everyone's familiar with Cummins and who we are, but if you're not, I want to give you a little bit of background on Cummins. Cummins is a global organization based in over 190 countries today, 73,600 global employees. It's funny, I love coming to these events because people are like, oh, you work for Cummins, do you know? Like 73,600 employees. I know many of you are probably in the same boat. I definitely don't know everyone at Cummins, but I've got a great cast here in the room today that I'll kind of gesture at broadly that'll be happy to talk to you about a wide variety of topics. We cover a broad range of power system solutions. A lot of folks, when they hear Cummins, they think about on-road diesel engines for the most part. And if I were to get up here and talk about on-road diesel engines for the next 20 minutes, you probably wouldn't be very excited. So what I do want to talk about is our power systems business unit and what we're doing in that space that makes it relevant to the microgrid space. Cummins develops a wide range of power generation solutions from diesel gensets, including Tier 4 solutions, to natural gas gensets, to batteries and fuel cells and microgrid controls, switchgear, transfer switches, and everything in between. And I know many of you who I saw in the booth, again, I see a few familiar faces who came by. I know the entire Cummins team was excited to talk about that wide range of solutions and why it's so important to this space. Relevant to this conversation today, one of the things that you're going to continue to hear from me is the importance of a variety of solutions. because the challenge that we all have ahead of us in the renewable and the clean energy future is not solved by any one solution. And if you don't take that message away from my discussion today, I don't think you were listening well enough. So I hope you've got coffee. I heard there was a coffee shortage. I hope you're wide awake and ready to go. And again, I hope one of the things that you take away from me today is that it's going to take a wide range of solutions to solve this clean energy problem that's ahead of us. I mentioned a number of different solutions. I also have to briefly mention Cummins' core business that's expanded into our Accelera business, which is also in the development of clean energy technologies. Everything zero emissions is in the space, including electrolyzers, fuel cells, batteries, and a lot of other on-road technologies. Not a part of our business that I'm going to talk a lot about today, but I am confident if you swing down to our booth, you'll see a few things related to our Accelera business. All right, with that, let's jump into the good stuff. We hear a lot about the industry pressures, and you're very familiar with these pressures that we're facing in the industry, right? The drive towards this increasing pressure to lower our carbon footprint is around us. It's all around us. Whether you are a small organization, or whether your customers are small organizations, small businesses, or whether they are the largest businesses on the planet, whether it's a data center owner or operator, or whatever you may be, you're facing, and your customers are facing, our customers are facing, this challenge related to reducing their carbon intensity. If you haven't heard that yet, I would be shocked. That's a big deal. I think it's something that we're all hearing a lot about. In addition to that, of course, there's an ever occurring drive to lower our operating footprint, or lower our operating costs, and of course, help our businesses to continue to be successful. Likewise, I know one of the other pieces that we've seen a lot, and I've talked with a lot of you about here just at this conference alone, is the increasing or maybe decreasing availability of the utility in a scale that supports commercial growth broadly, whether that is a 80 megawatt data center or whether that is a wastewater treatment plant or a hospital. I think we're all seeing and feeling the impact of the utilities, in many cases, inability to support some of these broad expansions. And that's not slowing down. That commercial growth is increasing at a rate that I think was unexpected by most of us here in the room today. And when we pile these together, I want to be very clear, this is not all of the pressures we're facing, but I think it represents some of the big ones. When we think about these things, and when we talk to our customers about these things, they say, I have the solution. I already know the solution, Mike. You don't need to tell me. The solution is I'm going to go build a microgrid. That's going to fix it. That's it right there. That's the solution. This one thing, building a microgrid, as easy as that, will help us relieve the pressure from all of these different pieces of the puzzle. And if I got any good eye rolls or chuckles, that was the intent. I think, as many of you may know, that it's not a one-size-fits-all solution, and the path there is not as straightforward as just doing it. And so what I want to talk about next is some of those challenges, those pressures, and how different technologies help to relieve those. Does that sound okay? Sound fair? Awesome. Thank you. I appreciate it. So I'm going to talk about 4 key things that build into what success looks like. These are not the only 4, and they're not even in an order that represents the biggest to the smallest. They're the 4 that are most apparent to me in my day-to-day, and I don't know that I gave a further introduction of myself, but I'm responsible for business development, as Alan said, for all of our microgrid and renewable solutions within the US, and that means I'm working hand-in-hand with folks like you and our customers who are trying to do this, and they're running headfirst into some of these challenges. And broadly, I'm going to categorize them in 4 major buckets. Again, don't go, Mike, there's a 5th one you didn't think about. I know there's a lot more out there. These are 4 of the big ones that I see. One of which is fuel infrastructure. The availability of the dispatchable resources to deliver power when it's needed in long duration applications, or even peaking applications where an intense amount of power is needed for a short period of time. Fuel infrastructure is one of the first things that we often see when talking about these wide variety of assets that are intended to be deployed in a microgrid. Sustainability goals. When we're talking to a customer, an owner, an operator, an investor, they're rarely exploring a microgrid solution for fun. Right? They're typically doing so because they have a drive, and that could relate back to that carbon intensity or that goal to reduce their carbon intensivity. I'm going to talk about performance because at the end of the day, the system has to perform the way we need it to perform. Whether that's a hospital that needs to be online in under 10 seconds in order to satisfy NFPA requirements, or whether it's a data center that just expects to be able to operate around the clock in case of the failure of the normal source. It could be a chip manufacturer or another high-tech industry that relies on solid performance and limited deviation on the voltage and frequency. It's got to satisfy the performance requirements. And last but not least, and again, in no particular order, there's got to be money available to do this work. Right? And we can talk about value stacking and how we connect the dots to derive additional value from these microgrid projects, but at the end of the day, if the money's not there for it, the project isn't going to move forward. And that's where some of these technology plays really come in to help make that easier. So one, I'm going to dive first into this fuel, one of the things I didn't cover is towards the end of this, I'm going to talk about a specific case study project that employs a number of different technologies, and I'll walk you through how we use that to validate future microgrid projects. So I'll get there. When I talk about fuel infrastructure, again, a lot of you may be thinking, well, Mike, I don't want to talk about fuel because we're talking about renewable projects only. Well, that's wonderful. I'm happy to hear that you're working on those projects. I think in many cases, in almost every case, and almost every time I've heard a case study shared up on the screen where someone's talking about battery energy storage and PV and fuel cells, and at the very end, they always say, and there's a reciprocating engine there as well to keep it running, right? That's the reality of it. And that's okay. There's nothing wrong with that. And I think we all need to just to look at that and say that's okay. And if that fuel infrastructure isn't there, no matter what technology that's being employed, whether that is, do I have a clicker that works? Oh, look at that. I'm that much more closer to being mobile. Whether that is hydrogen for a fuel cell, or for a reciprocating engine-based hydrogen solution, or whether that's natural gas, or whether that's clean diesel, that fuel infrastructure has to be there. That is an absolutely critical portion of ensuring these microgrid solutions are viable. Because as I said before, it takes each of these solutions put together to have something that really works and meets all these requirements. There's no one of these single solutions that's going to solve a microgrid challenge or a carbon intensity challenge without satisfying those other pieces. Got to keep that in mind. One of the ones that I don't want to spend too much time on, I know Ramon's going to talk about it as well, is HVO. A lot of times when we talk about fuel infrastructure and availability of clean fuels, we all jump to hydrogen or renewable natural gas, which are great options. And for the right technology, they're a great solution. I also want to highlight, and something you'll hear from me today multiple times, is that it's important that we consider the options that are available to us now, right this instant. Not tomorrow, not 10 years from now, but now. And one of those is something that looks a lot like clean diesel, HVO, which is available across the US regionally and can be dropped into existing genset solutions to help reduce the carbon intensity of those power systems. It should absolutely be considered as part of a microgrid solution with the right other pieces of the puzzle. Again, I'm not advocating and say the answer to your microgrid solutions is to run a diesel-based genset. That's not the case. The case is this is something that can be done immediately that can help to achieve those goals. One of the biggest advantages, it's low impact to the power system, and I think I'll let Ramon talk a little bit more about it. One of the ones that I highlighted is the drive around sustainability or environmental goals, ESG goals, whatever you want to call it, okay? And I'm not going to tell you what the right target is here. I can tell you that Cummins has our own targets, right? We have our own expectations, our own drive, and all of the major successful microgrid solutions that we've developed and worked hand in hand with our customers today have been driven in part by sustainability or carbon intensity goals from those customers. Again, no one's doing this for fun. Maybe some of us are. Is anyone building microgrids for fun? Yes? All right, we'll talk about where your money comes after this. The challenge with this is everyone's sustainability goals and directives are a little bit different. And so it's important to have these conversations up front and to quantify some of this. What does it mean? What are the correct metrics or targets that leverage these to ensure that it can help to motivate the project to keep moving forward? Because a low carbon intensity goal alone is not enough to get a microgrid project off the ground. It still takes all that other stuff, right? It still takes the fuel infrastructure. It still takes the funding to make it happen. It still takes meeting those performance requirements to move that forward. So this is important, but it's not the one thing that's going to drive a project forward. Performance. Again, I think very few of us are developing microgrids just to see how they work. They're typically being developed, installed, and deployed in order to satisfy a particular requirement. This may shock you, but the vast majority of the North America power systems are there for a code-driven reason. Whether that's NFPA or National Electric Code whether it's our healthcare expectations, power systems are being installed and evaluated because they have to be, right? They're there because there's a code-driven reason for them. There are other reasons that we often look at that help to shape what that complete power system looks like, and that could be things like continuity of business in our data center space or elsewhere. It could be actual revenue generation opportunity, which is great, but it's typically not just one of these things. It's typically a stack of the three that combine in order to help drive the motivation behind that microgrid project. And if that is a code-driven requirement, for example, it puts a very different emphasis on the technology solutions that need to be there. The way a fuel cell responds to a failure of the normal source may be very different than the way a reciprocating engine-based solution responds to a failure of the normal source. Likewise, batteries, and on and on. And so it's important to weigh each of the requirements, the performance requirements associated with the key driver for the project to understand the right mix of technology that needs to be there. Last but certainly not least, funding. And we can talk about, again, this is where we can talk about value stacking and how much can be derived from these projects. Funding comes in many different ways. I think many of us have talked and heard about the plethora of opportunities that stem from major policy shifts over the last few years, the IRA, the IIJA, and the many demonstrator solutions and many demonstrator projects available through DOE. It's wonderful. I think we're all very excited about it. However, there's still more work that needs to be done. We see a lot being done at the state level to help incentivize the use of different technology solutions at the microgrid level. But even with these solutions, there is still a gap. I've yet to see a commercial level microgrid installed without some sort of private investment to make sure it happens. It's got to be there. The funding's got to be there. I'd also highlight that where these incentives are available, it certainly drives the readiness and availability of the market to accept varied technology solutions. There's a lot happening right now. I'll highlight some of the work that's being done in Texas at the moment related to the incentivization of backup power packages, which you would objectively call a microgrid solution. It's technology-centric today, looking at natural gas, PV, battery energy storage solutions. And that's great, but it certainly drives a preference for the technologies in those spaces. It's important to recognize that these incentive programs are going to have that impact on the projects that we're all looking to deploy. It's important to recognize them and really appreciate where they're coming from, where they're trying to take us. I've walked through a lot of the drivers. One of the other challenges I want to talk about that really, I think, brings together all of these different solutions is really the validation of these solutions before they hit the road, before the rubber meets the road, to bring a term from our on-road space. When we see the need for these microgrid solutions and we see the deployment, a lot of times what we're seeing is that the first time these solutions, these products, these components are working with one another is when they all arrive on site on commissioning. I think what was said in the opening yesterday was that if you've seen one microgrid, you've seen one microgrid. And I absolutely do believe that to be the case. That's very different for the power generation industry, where we've seen a heavily commercialization of many of the assets that have been deployed over the last decades. What we haven't seen is commercial scale validation of those components before they reach the site. And this is an area that Cummins recognized as a major gap in our ability to serve the market and a gap in what the industry was prepared for. And so the particular study or the particular work that I want to walk through is a look at some of those gaps. And I talked about the integration of those pieces of the puzzle. I think, as many of you are probably experiencing, as we work to deploy microgrid solutions across the US, that's a multi-year project. Has anyone deployed a microgrid in 6 months or less? 1 year? 2 years? It's getting up there, right? It takes some time. How often are you finding the technology is changing in that period of time? By the time that the project is deployed, the products that are there are not the same products that you maybe started with. How does that feel from a customer standpoint who hasn't been able to experience the validation of those components in that broader power system? It's tough, right? Absolutely. So I think one of the things that you're going to see from both of us here is a little bit on the importance of that validation piece, and not just demonstrating how each piece works individually, but how it works in a broader power system. Whether that is a reciprocating engine-based solution that's fueled on natural gas or hydrogen, whether it's a battery energy storage solution of varying technologies, whether that's PV or beyond. It's important to understand how these systems work with one another to support the performance requirements of our customers. Cummins invested heavily and deployed our Power Integration Center just over a year now. Q1 2022, my slide says. So 18 months, a year, 2 years, 2 years ago now, has been operational. And this site on our Fridley campus, has anyone here been to Cummins Fridley campus? Cummins people, don't bother raising your hands. We'll consider this an invitation. Okay. This is a site that was developed to do the work that I think many of us get excited about here. It's actually putting the products together in a power system and seeing how's it work? Does it play nicely together? And that includes things, again, ranging from today, it includes a number of reciprocating engine-based solutions, so gaseous and diesel gensets, which we are excited to continue to keep there as part of that broader microgrid, alongside battery energy storage solutions of a relatively large photovoltaic array, and I am confident that as we continue to expand the facility, we'll see additional assets brought in. But it's not the microgrid that's the exciting part. It's being able to demonstrate how the components play nicely with one another and how they interact with our customers' loads so that we can demonstrate performance before the solution gets to the site. Because I don't know about you, but when we tell a hospital customer that they have to go offline for 7 days in order to validate the new power system, they don't get particularly excited about it. That's a tough sell, and it makes this microgrid space even more challenging. It's truly plug and play. One of the things we talk about microgrids, I talk about, hey, we've got a microgrid on our Fridley campus, and I hear, oh, I've got a microgrid too, and it's typically a fixed state. This solution actually allows us to literally plug and play different assets week by week or even day by day. In fact, it's more than one time where I've walked out of our Power Integration Center just to hear the circuit breakers clanging behind me in the switchgear as the system switches from a simple paralleling bus or simple common bus topology to a ring topology as it's trying to simulate the actual architecture of our customer site. I'm going to go ahead and wrap up. I presented you with a lot of information, and I hope that you took away a few things. There's a lot of pressures that we're all facing in the industry right now as it moves forward. There's a lot of different solutions that are available. I can continue rattling off that list that immediately comes to my mind. But the important thing is understanding how they work together to solve our customers' challenges and to relieve some of those pressures that they're facing. I also want to re-emphasize something I said at the very beginning. There is not one solution to solve this challenge. We all have a role to play in this space as partners here in this room as we work together to solve this broader energy issue. And there's stuff that we can start doing today. So don't forget about some of the technologies that are tried and true that are right in front of us, that have the option to evolve alongside the energy industry, and keep an eye out for what is ahead of us. I think we have a very exciting next few years and beyond. I have a lot of other resources in the space. I'm confident these slides will be shared in some way, shape, or form. So I've got a few other slides that I'd be happy to walk you through. But with that, I will go ahead and wrap up my portion. Thank you. Excuse me to unplug here. I guess that.
Very good. Thank you, Michael. Excellent presentation as always. Next up, we have Venkataramana Ramareddy from Rolls-Royce Power Solutions. He is the Senior Manager of Automation and Electrical Engineering at RRPS. So welcome, Raman. Let me get this out of the way, and you.
Good afternoon. This is Raman from Rolls-Royce. I'm responsible for controls automation and electrical engineering for 60 Hertz market. So today I'm going to go through the presentation similar to what I did yesterday. I got some good questions yesterday in my presentation. So I'm going to do the extension of that. First, I'm going to introduce about the company and then go through about the solutions what Rolls-Royce provide and a validation center and later into sustainable fuels. So similar to what Michael said. So moving on, yeah, we are part of Rolls-Royce PLC UK. So we work in power systems. So we are responsible for the power generation here in Americas. So I myself and along with two colleagues, Justin and Arun, are also here. So if you have any further questions regarding sales, we are all available. So any questions if you have, please feel free to ask any one of us. So yeah, at a glance, if you see here, we are a 4 billion business in 2023. So I have to update the slide. But what I want to emphasize here is Rolls-Royce have business about 34% into power generation. That's a lion's share. So Rolls-Royce is fully committed to invest more money into research, like what the market needs. And what do we see as a microgrid, how our validation center looks like. So those are the things I'm going to talk in this. So we are present both in 60 Hertz and 50 Hertz market. So we are present in over 175 countries. So yeah, we serve variety of customers, right from data centers to utility grids and also telecommunication and also small scale industry sectors. So yeah, I just want to show where we are present. So we are a traditional engine manufacturer company if you see us some years ago. So we transformed ourselves into a solution provider. So we saw a need in the market and yeah, that's how we are going to be. So we are in the transition phase actually. So we are moving, I mean, I won't say moving away. So we are transitioning. So what we can do better with our internal combustion engines and what are the other products that will be a good addition for us. So that is what our strategy for 2030. So if you see here, the need for the energy is keep growing, so year by year. So we get a lot of requests from our customers for backup power and also for primary power. So in order to fulfill the needs of our customer, so we have put together some of the systems. Yeah, it's a cloud-based system. What I'm going to show in next couple of next couple of slides. So we have a product called Energetic IQ, which is capable of automating the whole plant. So if you have different distributed energy resources, you can automate that using our Energetic IQ platform. So we do have products in that platform. And these are the systems you can actually integrate with this software. So anything, whatever you see here can be integrated with this. And apart from this, so we do have marine automation and rail automation as well. So we also work with some of the marine customers for their power generation needs. These are the solution offerings what we have, right from the internal combustion engines and also dynamic uninterrupted power supplies, battery energy storage systems, fuel cells. So we also work with some of our partners to have the availability of hydrogen gas and also HVO. So this validation center is located at Friedrichshafen, Germany. So you can run any of the sequence. So just like Michael told, whatever your need is, if you want to just run a diesel genset with a battery container or gas genset with something else, you can run any energy using this platform, Energetic IQ, at our validation center. So this is what it looks like with our system with the different energy resources. So we do help our customers how they can stabilize the grid, peak shaving, for backup power, and also for customer-specific application. If they want to run all these assets not as standby, they also can run as primary. So these are the selected market applications where we serve. So right from energy shifting to peak shaving, spinning reserve, ramp rate control, voltage regulation, frequency regulation, so we can fulfill any of the needs that customer have. So I just kept one project here. The reason for this is some of our customers, they still think they need gas generator or diesel generator together with the battery container. So this is due to fulfill the power fluctuations they get from the grid. So the fast responsive time of the internal combustion engine gensets is one of the reasons they still want to have the generator in their microgrid system. So we have commissioned this, and it's a really good example. I thought it is a really good example to present here. So they don't have a power failure since it is commissioned in 2023. Why we are emphasizing internal combustion engine gensets? Yeah, there is a carbon emission with it, but you also see a response time and flexibility with the internal combustion engine gensets. So if you need to have a safe power in event of outage, you have one asset available which can take care of your need before the utility come back or before a battery charge with a solar farm or something like that. So for that reason, we thought, okay, how can we better with our internal combustion engine? What can we do better by emitting less carbon dioxide? So we went with the alternative fuel strategy. So if you see here, we started researching about HVO and H2 gas. The 90% reduction you see here is from well to wheel ratio. I think some of you has asked, will it be 90%? So we calculate the 90% like this. If you see in this slide, it's right from combustion, you emit into environment, and it will multiply if you emit that carbon dioxide. So that's how we have calculated. So this is one clarification I want to give from my yesterday's presentation. And just a comparison between a fossil diesel and a HVO. So you see the clean emission here. So we highly encourage our customers to use this. So you have less emitting internal combustion engine with this fuel. This is the comparison between a normal diesel emission to HVO. If you see the numbers here, it's way less. And the performance. So yeah, performance is a good criteria we need to discuss about. If you see the load steps we ran, this is from our lab, with 25%, 50%, and 75% and 100% loads. The performance of the both systems with the different fuels is the same. So you don't have any loss of performance. So to summarize, what is HVO? So it is good to reduce the pollution, and it's a simple drop in fuel. You can just drop in that fuel into our engines. You can use it. So you need not to do anything like remanufacturing or refitting or anything. So our engines are readily available to work with this fuel. Right now, HVO, I mean, like back in the days, it was not abundantly available in world, but we are also partnering with some of the companies like Neste. So we have a partnership with them. So we want to bring this fuel as much as available to our customers in all the continents. So we have a strategic partnership with them. So next, moving on, the natural gas, the alternative for natural gas. So we thought it will be a good idea on the hydrogen. So right now you can blend the hydrogen and use it on our natural gas engine. We are working towards the 100% hydrogen engine by 2030. That's our next strategy. So if you see the performance, I think it's you yesterday who asked this question, right? I kept this slide for you. So if you see the gas engine, if you do the blending of the 25%, you still have the same performance. But if you use the hydrogen, in our gas engine, it is derated as of today to 60%. So we are working on this, how to make it better. If we use complete hydrogen in our engine, how can we get the good performance? So we are changing our engine design so that it will give the full performance. So that engine we are expecting to be ready by 2030. So we also provide some of the conversion kit as of today to convert our natural gas engine to hydrogen. And if you see here, you change the piston design, multi-point injection. So we do also have the design where you can inject both fuels and you get the same performance. So yeah, different kits are available. These are the parts that is part of the kit. And like I said, we are expecting a internal combustion engine with the full hydrogen gas by 2030. Sorry, I'm just messing up with my slides here. We also worked last 5 years with fuel cell. So right now, I want to be fair. I don't want to say anything that is not happening. So the storage of the hydrogen is the biggest issue. So I mean, also the transportation, the availability of the storage. So right now, we paused our fuel cell because of this logistic problem with the hydrogen. And we are encouraging more research towards our hydrogen gas engine that might be available by 2030. So yeah, if you have any suggestions how to handle the hydrogen logistics, we are happy to take their feedback. We are happy to partner up with them. So this is one thing I want to emphasize. And yeah, thank you. That's it from my side. If you have any questions, I'll be available.
Okay, we have plenty of time for questions. Just raise your hand and we'll take it from there. Right here in front, thank you.
More. We do have a microphone. Oh, thank you very much. So the question that I heard, there we go. The question that I heard was the cost on HVO versus traditional diesel fuel or natural gas. And I think one of the challenges that we often see with HVO is the regionality. So one, it's just the availability of it region by region, but also the cost tends to fluctuate region by region as well. I generally see it as, I'd say significantly more than diesel, and that makes it challenging to substitute for maybe an entirely code-driven market that is not driven by a sustainability goal. That's why I talked personally about kind of those four things intersecting, right? Because if there's not the drive to achieve that lower carbon life cycle of that project, it's not, they're gonna have a hard time, that owner may have a very hard time justifying the additional expense for the HVO. I've seen it $1 to $2 more per gallon than diesel.
Yeah, actually it's in the field. Right now, most of our customers, like big customers, they are moving more towards the HVO. So once the availability is more in US, I think they want to use more that way. Okay.
Questions? I don't want to sit.
Yeah.
We're going to stand and answer questions. I
Okay.
don't like sitting.
Other questions?
Yeah, please.
Yes, sir, right down in front.
Michael, I think you brought this up, but I'm curious from a generation standpoint. In your facility, you're able to simulate ring topology. I'm curious, in the U.S., if you're seeing a rise in that, if that's something you're driving, does it make it easier, or are there advantages from your side towards that, or otherwise?
The question specifically about the topology?
Yeah.
Yeah, so I gave that example as a compare and contrast. And so that site, or that's a really bright projector. That facility, I think that's better, thank you. That facility was really intended to be able to do kind of whatever we needed it to do. And so whether that is a simple paralleling bus with a couple of different assets on it, or whether it is a more complex topology like a ring, we're able to do that there, and everything in between. Are we seeing more of that particular system architecture? I wouldn't say so, not necessarily. I think you know, in certain certain sub-markets, I think we're seeing a shift from a common bus to or to shift towards a central plant style topology, which is interesting depending on the application, whether that's hospital or a data center. But I'm not seeing a shift towards ring that I can comment on. No. Yeah.
The questions?
Same thing.
Right in the back.
Michael, you mentioned and showed us about the kind of controls you are able to do test in your lab,
Yeah.
but you did not mention about the optimization of resources. Are you doing it yourself?
Yeah. A really good question, and I'll, if you can speak to it as well on the validation site. But yeah, the question was on demonstrating optimization of assets and energy production versus just putting them together and seeing if they work. And again, my background is engineering. I loved Legos as a kid, and so I love clicking all the pieces together and seeing how it all works together, but that's not just enough. On one hand, it is important to demonstrate that the way a fuel cell will react to a large motor load. That is super interesting because it's different than the way it reacts to the utility, and it's different than the way it reacts with a large mass or a large inertia device like a genset. And that's great, but there is also the optimization standpoint for, say, like an off-grid, let's call it a prime application, like a remote mining operation that's trying to balance a number of resources. And that is something that we can do. We actually have the engineering and modeling resources in-house in order to help projects navigate through that complexity. And we use different software platforms in order to help us get there. But that is an absolutely important part of that, because it's very easy to say, just more batteries, no problem, right? You need 1 megawatt-hour batteries? Let's do 4. There's a cost associated with that, right? That's not a fair assessment. And so it's really important to be able to show, for a particular load cycle, these are the assets that help you get there while maintaining the cost, because there's that funding piece of it too. Thank you for the question.
Okay, we can do similar thing as well, like grid forming, grid following, whatever the optimization you need, which one will go first, which will form the grid. So we can run different sequences according to what a customer needs.
Thank you. Other questions?
Maybe on this side of the room, quiet side. Yeah, there it is. Thank you.
Right in the front. Good.
We have one at South Carolina that's in our own facility. So it is a grid. It's a grid forming microgrid that serves our own facility. It will take load of our manufacturing facility. So it has battery, it has solar, and it has a diesel generator which forms the grid. So it's a live center, so providing the load to our own manufacturing facility.
I'm not here to revive the conversation on what is a microgrid. Every one of these conferences I go to, we start with the conversation, what is a microgrid? And I don't want to step on that today. But we've been developing microgrid solutions for decades, right? I mean, that's the reality of it. You want to talk about the mix of assets that are included in there? Yes, absolutely. We have live sites that are mixing assets. I think there's one that is heavy on my mind. That is it's a defense, I can say it's a defense-related program that includes a mix of assets, including gas gensets, diesel gensets, battery energy storage, photovoltaic, and the works. And it's a tiered or a ring style, not that ring, different, kind of a concentric circle style community microgrid that's able to expand and contract based on the power demand. And that's been in operation for a few years now, and is certainly one that I think is demonstrating the capability here. Great question, thank you. I love that. That came up in the panel earlier in the week. It was like, all these exciting microgrids, how many are actually through the implementation phase? And it's like, we're getting there, right? I think that's important to recognize in this forum. It's evolving.
In the back there.
So the question, and I'm really glad you added that last part on there. The question is there anything else on the market today that has the same performance characteristics of a diesel generator set that isn't a diesel generator set? I'm going to go with, that's pretty hard no in my boat, from my standpoint. It is, to solve the performance requirements, things like the heavy block loading, the low emissions, the prolonged duration, it is absolutely a mix of assets. This is what we're seeing today. And I'm not talking about battery and solar. And nothing against battery and solar, but to achieve all of those pieces of the puzzle in any application broadly, it does require a broader mix of assets. And that could still include a diesel genset. It could still include a gas genset alongside battery PV. But in that case, the cost isn't the same. Yep. Do you want to add anything? I can.
This is
continue
a
to comment.
engine technology forum. I'll say no. So support diesel. Okay. Yeah, maybe with the gas, we can perform that. So, but not definitely like Michael told, not on the asset level of battery or solar. That's a different story. So as of today, yeah, diesel is still strong.
Yeah, so
Yeah.
this is where that funding piece is really important, right? Because you're absolutely right. The big disparity today is in the cost of the cost of the equipment as well as the execution, and where there are many opportunities, or where there are many, whether it's state level programs or even local programs that are able to help close that delta or bring that closer. That's where we see. That's where I see better opportunities to hit that same level of performance. Because otherwise, the cost is it's not quite there yet. Just to be gentle about it. I say, who said clean diesel? There are, you talked a lot about HVO. HVO to me, yeah, go ahead if you want to talk about that.
So HVO for us is almost a clean diesel. It still emits the carbon dioxide, but as of today, we feel that is the only strong alternative for diesel. So that's the reason we call clean diesel, but it still emits the carbon dioxide.
And combined with like a tier 4 solution, it can further reduce that and
Yes.
still be at and still satisfy those performance requirements alongside other assets that can help to further decarbonize that power system solution. So a tier 4 with HVO alongside battery, alongside maybe a fuel cell solution, can give you the right mix of hitting that performance as well as not having to operate solely on a compression ignition-based resource. Although it's a great option in the immediate.
Questions?
Oh, sorry.
Any comment on DME fuel, dimethyl ether, as an alternative to HVO and alternative?
We don't see it as of now. So yeah, we don't do any research in that region. The reasoning. No, we don't have it.
Cummins is, we're constantly exploring different fueling options, and our portfolio continues to evolve. Yeah, HVO has been one that I think right now we're talking a lot about because of its growing availability, which is great. But there's other fueling options that we're exploring to ensure we have the right technology. We're, I think, like many of you, appreciative of how messy this period of time is, this messy middle as we transition and work through this bridge. We recognize that there's going to be probably some lead technologies that arise over the next few years, but in the meantime, I think we're all exploring the right solutions to ensure that we have something that can help our customers achieve their goals now.
Yes.
Matt Weaver, TKN. I'm curious, I see you both have hydrogen equipment in your portfolios. Is that more of a long duration energy storage play, or how do you see it as a family of products?
At least we see it as a long duration. So yeah.
From Cummins' standpoint, we're heavily invested in the hydrogen markets through a number of different avenues. One of our key drivers is the on-road space, to be complete and totally honest here. We see hydrogen usage for long-distance on-road trucking for the most part as being a suitable substitute or replacement for battery energy storage and EV vehicles, which are maybe better suited for short distances. In the same space, in the power generation space, we see hydrogen in two major areas. One, as long-duration energy storage. So the idea of basically turning free energy through excess renewables or whatever it may be into high-pressure hydrogen storage that can then be used at a later date. That's wonderful. I think there is also an opportunity for different applications where you're actually converting that hydrogen back to electricity to maybe fuel an EV fleet. There's different opportunities for it. We're certainly exploring a lot of those right now. Fuel cell solutions for standby-ish applications are something that we're looking at. And I can also comment on the mobile market as well as something that's actively being explored from a hydrogen standpoint. Yeah.
Yeah. Other questions? Yes.
So, with this recent trend in data centers and these large loads that are opting on a prime power to off-grid solution with grid bridging capacity, so this is a trend that we're going to see a lot. Do you anticipate that your current or your forecasted manufacturing capacity can capture that, or there will be like I'm trying to think about how we can close this gap here to not have a lot of backlogs, but doesn't have.
There it is, the lead time question.
Yeah, there is a problem with all of us. So we do have long lead times right now. So, but we are putting all of our efforts to manufacture more engines. So right now, engine availability is the biggest problem. So we can assemble the genset, but we need to produce the engines. So we are expanding our production lines, both in Europe and US. So we want to meet the demand of the data centers in the next 4 or 5 years at least. So yeah.
Just so, that's okay.
For us, it's 2 to 3 years.
So just so everyone heard the question, certainly around the infrastructure needed to support large megawatt, multi-megawatt, and I'm talking 60, 80, or even sometimes smaller than that, depending on the region, and seeing the utilities maybe unable to serve that in the short term. We're seeing some customers turn to on-site generation. Well, if we can't be served by the utility in the short term, let's do it ourselves. And when it becomes available, then it's the cheaper alternative. Wonderful, amazing. And so the question that you asked specifically was, if the industry was already challenged to serve kind of the normal market, which is typically standby, and now we're seeing a shift to standby and prime, how is the industry responding from a availability of resources? And I'll say it's definitely been a challenge. To be nice about it, it's been a challenge. I think that I know Cummins has worked, like many manufacturers, very hard in order to improve our manufacturing capability and bandwidth in order to support a lot of it. And if all of a sudden we were to see significant growth in certain markets that wanted to shift to this prime application, it would be something we'd have to respond to. And I think we've done a good job at ramping up towards it. Right now we're 60 to 80 weeks on a high horsepower generator set right now.
Other questions? I'll finish maybe with one here, and that is to do with policy. And I heard a comment earlier today that folks don't want diesel, quote, quote. But the reality is maybe something otherwise, which you heard from both of you. What are we seeing relative to the policy space that either encourages microgrids to be inclusive of all these technologies and to really offer the flexibility that's needed based on the site customer demands versus ones that are more sort of stuck in an idealistic world where it might be nice to have, but it's not available now? What are we seeing in the policy space that drives that one way or the other?
Yeah. So one of the things that I'm seeing a lot of today across the board, and it's been the norm, is technology-specific policies. So the promotion of a specific, let's call it a program that supports a tax credit for specific technologies, like a fuel cell, for example.
EVs.
EVs.
There you go.
Sure, let's do EVs. The challenge with something like that is Of course, it may not be based in a broader performance metric, and it may drive what I'd perceive as maybe the wrong behavior. What I really like and what I heard a lot of yesterday and some today is recommending a shift in those policy targets towards resiliency-based targets. So looking at maintaining uptime or maintaining availability of power to a region or sub-region or a community by whatever step necessary. I know at the local level we see specific restrictions on technologies. So some of our states on the West Coast have put in place certain policies that limit the sale and operation of internal combustion engines. That's very challenging to then kind of look at the remainder of what's available and go, how do we solve this problem? And I think someone had a really good example in the policy workshop yesterday that talked specifically about how they kind of fell backed into a corner based on what was left, and that's the stuff that I don't like seeing. So I like to see more broad performance-based targets, not so much the technology-specific targets.
Ramon, number 2.
Yeah, I mean, like you can give incentives, and if it is not a good model, that is what it is going to be like electrical vehicle, right? Like you need to have grid resiliency, like Michael told. So you need to encourage all the industry players by giving them benefits and seeing what is possible and what is not possible. You can't say just like, okay, battery is a good solution, you go ahead, get it done. And now you see like, okay, a lot of EVs in the lots of the car dealers. So then they realize battery is not a solution. Now they're coming back and searching for alternative diesel solutions or gas solutions. So you need to see the future, what is possible and what is not possible. So you have to encourage for a standard grid, not for just sustainable products or something like that, who can make the grid more stable.
Very nice. I think that's a nice way to end it. And I want to thank all of you for attending our session today. And a big round of applause for our 2 speakers, Michael and Ramon. Thank you. Don't forget to rate our session on the app, and we'll look forward to seeing you around the conference and in our exhibit at the exhibit hall and other places. Thank you.
Thank you.